My dear students, I'm your Anusuya ma'am. We are going to see about the next topic in the crystal physics, that is crystal defects or imperfections. So this is the final topic in this crystal physics unit. So I think uh, you all enjoyed the last topics in the crystal physics. Anyway, now we are in the stage to complete the final topic of this crystal physics. So before starting the class, so every day we are thinking about any one quote. So today we are going to see about the quote about the education or the learning is. So the beautiful thing about education is that no one can take it away from you. So I hope you understand the meaning of this. So the positive of education is no one can take anything from us. So if you study any degree or any other thing, or if you learn something, no one can take from your mind. So other things, suppose if you are having too much of money or too much of that means materials, other materials, if you have, the people may take from you. But the only thing, the learning or the education, which is the one which no one cannot take it away from you, right? So we have to give importance to that. So the next, our topic is already I told you, crystal defects or the imperfections. So from the name itself, you can understand what do you mean by the defect and what do you mean by imperfections. So in general, human being, we are all have some positive and negative character. As like that, the crystals that also have the some characteristics of positive and negatives. As like that, the negative character of a human being, the crystals also have the characteristic of defects. It may have some structural defect, or we can call it as imperfections. Defects means some problems. So that's the defects or imperfections. Okay. So atoms in real and ideal crystal. So before starting that, this is the origin point. So ideal or perfect crystal. So if you take a perfect crystal, in that all the atomic arrangement is perfectly regular and continuous. I already told you crystal means it have a regular arrangement of atoms. But in regular, that means a real one, if you see that the orientation of atoms will be disturbed. See, that's a nature. If you want to tell about the perfect one, there will not be any problem. But for the actual or the real crystal, it has some disturbance. The orientation of atoms have some disturbance. That disturbance may be at a point, at any one point, or a line, or any region. Okay. So if you take a perfect crystal, all the atomic arrangements are perfectly regular and continuous as the whole throughout the crystal. But for the real crystal, if you take that, the regular orientations will be atoms orientation will be disturbed at the point or a line or a region. So we are going to see that one. Defects or imperfections. So defects is nothing but disturbance occurred in regular orientation of atoms. If any disturbance in the regular orientation of atoms, we call that one as the defect. And these defects, why we are going to study means the properties of crystals may change based on the defects. So that we are going to focus this defect or imperfections. So the properties of crystals are structure sensitive or structure insensitive. Structure sensitive means the properties may affect, or structure insensitive means it will not affect. Okay, so that's the case. So structure sensitive means properties will be affected. So what all other properties may change means growth of the crystal, hysteresis, or a strength wise. If you take mechanical strength, if you consider these kind of properties may affect by the disturbance of atoms. So structure insensitive means the properties will not change. That is, it will not affect the properties. So example for the structure insensitive, stiffness of the materials. You know how rigidly it will be. The material may be we have. So that's a stiffness and density. Classification of crystal defects or imperfections. So classification means different types, so what are the types of crystal defects or imperfections? So this is the explanation for the classifications or the types. First we have to divide defects as point defects, line defects, surface defects, volume defects. Four defects. In the point defects we are having a three different types: vacancies, interstitial, impurities. In the vacancies, we are having a two types: Schottky or Frankel. Some other also will be there, color center also there, but here we are going to study only Schottky and Frankel. And under the case of interstitial, we are having a self interstitial and foreign interstitial. For the impurities, substitutional or maybe substitutional impurity, or maybe another one type is interstitial impurity. Second, line defects will be divided into edge dislocation or a screw dislocation. In the edge, we are having a positive and negative edge dislocation. In the screw, we are having a left and right-handed screw dislocation. And for the surface defects, we are having four defects: grain boundary, tilt and twin boundary, third twin boundary, tilt and twist boundary, third twin boundary, fourth stacking fault. And as the final most volume defect, it may be cracks or pores like that, so that's the one. So totally these all are the classifications of the defects. So point defects or vacancies: if an atom is missing or irregularly placed in lattice structure. See, from the name itself we can understand vacancy means any one of the atom missing in the particular lattice structure, lattice point, lattice structures. So we call it as, if any atom is missing or any atom is that is what we have to say, irregularly placed. Irregularly means it is not placed in the correct position, right? So that's a irregularly placed. So any atom is missing or irregularly placed, we call it as point defect. One of the point defect type is vacancy. Look at the picture. There is a arrangement of atoms. In the arrow mark, it shows the place of arrow mark. It shows the vacancy. There is a missing of atom. So this is the vacancy. And Schottky defect or pair vacancy. I already told you vacancies have a Schottky defect. Another one is a Frankel defect type. So Schottky defect means that's a pair vacancy. A pair of ions will be missing. We call that one as the Schottky defect or pair vacancy. Look at the picture. In that picture, you can see that in the place of C, there is a one negative anion and one positive cation. Both are missing. A pair vacancy. Pair of vacancy, ion, positive and negative ion vacancy, that is cation and anion vacancy, di vacancy, we call it as Schottky defect. And Frankel defect. So in the Frankel defect, look at the picture. Here there is an atom which transferred from lattice site to interstitial site. See, look at the picture. Vacancy means missing of atom. Interstitial means a small gap in the non-lattice structure. Non-lattice point structure. That means what is that? Say a small gap between the arrangement of atoms, So that is the interstitial. So some atom, any one of the atom may fall to the small gap in the regular arrangement of atoms. So interstitial means small gap. Interstitial means place in a small gap in the arrangement of atoms, right? So look at the arrow mark of interstitial site. One positive K plus, K plus, that is a cation ion. That ion is moved to interstitial site, So this is the one we call it as Frankel defect. So cation transferred to interstitial site or moved to interstitial site and create a vacancy, we call it as Frankel defect. Then vacancy is another diagrammatic explanation. Look at that. In the Schottky defect, look the diagram. There is a dotted lines which have the arrow mark shows Schottky defect. Schottky defect means in place of Schottky defect, you look at that one positive ion cation, one negative ion anion, both are missing. So we call that one as the Schottky defect. In the Frankel defect arrow mark, you look at that one small positive cation is placed in the interstitial site. That means a small positive cation placed or moved to a small gap in the regular arrangement of atoms, and it makes a vacancy in its position of positive. That is what we are telling Frankel defect. A positive cation moved to interstitial site, we call it as Frankel defect, because it makes a vacancy in its own position. Interstitial means, I told you, a small gap in the regular arrangement of, or void. We can say other name for this one is void. Void means a small gap between the regular arrangement of atoms. So self-interstitial means what is the atomic crystal? The same material is positioned in the interstitial site. We call it as self-interstitial. Foreign interstitial means impurity atom occupies the interstitial site. So look at the first diagram. That is for self-interstitial. Same material is placed in the interstitial site. For the second diagram, look at that. In the regular arrangement of atoms, impurity atom or a foreign atom which occupies the interstitial site. Interstitial means what is that? The gap, a small gap between the regular arrangement of atoms. So that is an interstitial or void. The point defects, third one is impurity. So the impurity defect have the two types, substitutional and interstitial impurity. So first one is substitutional impurity. Substitutional means replacement. So it just replaces the parent atom. The impurity atom replaces the parent atom. A substitutional impurity refers to a foreign atom or impurity atom replaces the parent atom. Look at the picture. In that case, substitutional impurity, which is the arrow mark shows, in that place the atom is replaced by impurity atom. Regular atom will be one, but this substitution will be different. And next one is interstitial impurity. Interstitial impurity means, interstitial, just now I told you, a small gap between the arrangement of atoms or a void in the arrangement of atoms. So the interstitial impurity means the impurity atom is placed in the interstitial site, right? That's the case. Interstitial impurity is a small size atom occupying the empty space in the parent crystal without dislodging any of the parent atoms. Without dislodging means it doesn't exit any atoms from the regular sites. So simply, if you want to say, substitution means we have to replace a parent atom, but interstitial means the impurity atom which is placed in the interstitial site or a small gap between the regular arrangement of atoms. And line defects, the defects due to dislocation or distortion of atoms along a line. See, look at that. Distortion means just in Tamil we call it as விலகல் அப்படின்னு சொல்லுவாங்க. So that is distortion of atoms along a line. So through the line there is a sliding of atoms. So that's why we are telling line defects. So this will be happens during crystallization process. So it have two types, edge dislocation and screw dislocation. Edge dislocation, look at the picture, you can understand. In the first picture you see that in the bottom we have a 4 atoms. Another layer of the bottom we are having a 4 atoms, and next third layer you see that 5 atoms are there. Over that we are having a 5 atoms, and in between there is a dotted line. These two layers in between there is a dotted line. The dotted line, just that is the slip plane. We call that dotted line as the slip plane. Why we are saying the slip plane means only from that there is a change in the atomic planes. So extra one plane is above the slip plane, right? That is what we are telling. In the line of slip there is a change in its addition of plane. So we call this one as the edge dislocation. So edge dislocation means what is it? It's a defect produced due to the insertion of an extra half plane of atoms into crystal lattice. Extra half plane, if you see that you can understand. Yes, here this is the point is which we have to understand. This is the extra one compared to others. Likewise here if you look at this diagram, here also this is the extra plane. So the extra plane insertion, half plane insertion in the crystal lattice, we call that one as the edge dislocation, and this dotted is the slip. We call this one as the slip. And here this is also the same. Here also you look at the picture, this is A and B, extra half extra plane insertion. AB is the plane, this is inserted here in the top. So if the plane is inserted from the top, we mark this one as, give the symbol as edge dislocation, positive edge dislocation. Suppose if any bottom to top, then we mark that one as, if the plane is extra half plane has been inserted from the top of the crystal, if the top of the crystal, if it inserted, we give the symbol as inverted T. If it is bottom to bottom of the crystal of extra plane inserted from the bottom of the crystal, we give the symbol as T. Screw dislocation. Screw dislocation, that's a case, you just imagine yourself. One part of the crystal lattice is shifted relative to the other part. Other part will be in the same place, but in the other part there is a sliding of the crystal. That means shifting, small change in its position, that is we are telling it produces a defect. We are telling screw dislocation. It's an helical atomic displacement around a line extending through the crystal. That means what is that here? It just looks like a screws in the ordinary what is it, bolt or nuts, so we are having a screws. So in that screws some small layers will be there, likewise here there is a one part of the crystal shifted, crystal lattice is shifted, and it will be looks like a spiral ramp. Spiral ramp means what is it? One circular change, rotation. So it just looks like a spiral ramp. So this is the one we call this one as screw dislocation. If you look at the picture, you can see that the screw like defect. So we call this one as screw dislocation. The spiral motion of one part of the crystal is in clockwise. If the spiral motion of the one part of the crystal, if you shift one part of the crystal as the clockwise spiral motion, we call that one as the right handed. If you shift, or if you move, or if you are going to give spiral motion of the part of the crystal anti-clockwise, you say that is left handed. Burger vectors. Burger vectors, that's very important for the next defects, so that we are going to see burger vectors. So the burger vectors, we have to mark b vector, small b vector. It's expressed by that is dislocation line. Burger vector is nothing but dislocation line, that is defect line. It indicates the magnitude and direction, amount and direction of shift, how much it moves from one place to another and in what direction, right? That is the thing here. So in this picture you see the first picture perfect crystal, second picture is dislocated crystal. Perfect crystal means you look at the point of P. So if any one, the dislocation line starts at P and ends at P. So in the direction, arrow mark shows its direction. So the dislocation line starts at P and ends at P. That is a perfect crystal. For the dislocation located crystal, look at the picture. The P is there, capital P, but it starts at the P and it ends at Q. So there is a variation in the P and Q. That PQ is equal to B vector. That B vector is the burger vector, right? And the path we are marking, P and Q, that's a loop, burger loop, or we can call that one as the burger circuit. For the perfect crystal, the circuit completely closed. It starts P and ends at P. For a dislocated crystal, it starts P but it ends at Q. So it is a opened circuit, burger opened circuit. Grain boundary, last surface defects. Grains means the arrangement of atoms in the first grain is different, and look at the second grain, that is in another orientation. So in between these two grains will be separated by a layer, that is grain boundary. So the defects occurred in this boundary, we call it as grain boundaries. And a tilt boundary means, tilt means there is a low angle tilt, we call it as tilt, just slide, low angle tilt. First grain left hand side, second grain right hand side. B means burger vector, and D means dislocation, capital D, and theta is the tilt, So these all are that. And in the place you are having this one, this is positive edge dislocation. It shows positive edge. If it like this, positive edge dislocation. If it is like this, negative edge dislocation. And in the next, tilt boundaries, and next one is a twist. Twist boundaries means it is a one which have the two screw dislocations, and also it have the normal to one another. Its plane should be normal to one another. Twin boundaries. Twin boundaries means, so the first perfect region is there, last one, that is also perfect region. In between that there is a distorted region. Region here, that is a sliding region, so that is here, that's what we are telling. The distorted region, that's a defect in the two perfect regions. We call this one as the twin boundaries. Both the perfect region In between we are having a distorted region. And a stacking fault. Last one is the stacking fault. Stacking means it's a accumulation of the atoms. And stacking sequence means accumulation of atoms in the order. See the order of the accumulation of atoms. First picture, in the bottom you see that capital A, next one B, A, B, C, A, B, C, A, B, C. Stacking of atoms or accumulation of atoms are in the regular order. Look at the B picture. The sequence is not correct one. There is a change or a defect in it. That's a fault. Look at the bottom part, A and B and C, A and B, and next one is there is a fault, so we are having AB. So there is a large difference in the accumulation of the sequence of accumulation of atoms sequence. So that's a difference. Both the diagrams there is a large fault. Compared to the first diagram, the second diagram is having a fault. Okay. And role of imperfection in plastic deformation. So role of imperfection. So already you know that if you are having, you just imagine yourself that dotted line rectangular one is the regular crystal. You are going to give some pull to that. That means you are going to apply force. While you give that, it will deform its shape. It slipped. The crystal slipped. So if you give any force and if it has changed its shape, again if you remove the force, it will comes to original state, means you say that is the elastic one. For example, rubber you take, you are giving some force and you are giving the force, you are just release the force of giving, you are going to release just. If you do that, then what will happen? Automatically it will come to its own position. That is elastic. If it does not comes to position, you say that is the plastic. Likewise, here in crystals also there is a plastic deformation. That means if you are giving any force to the crystal, it will change its shape. Again, if you release the force, it will not come its original state. That's a plastic deformation. So there is a change in its length. Dotted one is the original one, and next one is the change in its length. That is a variation. So in the dislocations, if you are giving stress, then it change its state, that is deformation. It will be deformed, that is elastic. If you release it, again it will come back, that is elastic. If it doesn't come to its original position, that is plastic. So look at the picture. Presence of dislocation. If any defects or dislocations will be there, means then definitely it should have a slip. Slip means there is a slide displacement of planes or atoms, whatever may be that. So if it have a slip, means automatically it have a plastic deformation. Plastic deformation means what is that? There is a change in its dimension, but it does not comes to its original position. That's a plastic deformation. This is the connection between these three. So students, I have given some questions for you. You please read the questions and answers. Give answers in the comment section of this video, and we will see the answers in the description box after some days. Okay, I hope you all enjoyed this session. So answer these questions in the bottom of the comment section. For example, first question, what is answer? 1, A, B, C, D, whatever it is, you write. Second, third. So up to that you write. Okay, thank you so much for listening my class. So I think this is the last session of this crystal physics. Thank you so much.